In this lecture video, we're going to walk through some of the Excel formulas that you'll be using for both this problem set and when coming up throughout the rest of the course. Now, the data set we're working with here is different from the one that you'll be using for your problem set. This is a real data set of diamond prices and characteristics that I found somewhere online. So I want you to see these Excel skills being applied somewhere new, so you're practicing the thinking, not just literally copying what I do step for step. Now, before we build anything, let's look at the data that we're working with. So column A here is the ID. That's just a unique number for each individual diamond. We have the carat, which is the weight of the diamond. Then we have in C, D, and E, these columns, we have cut, color, and clarity. These are all categorical variables. In F and G, we have depth and table. These are measurements of a diamond's proportions. And for this data set, these are given as percent. So this 61.5 is actually 61.5%. The H here is price. And yeah, this is in dollars. And then I, J, and K, X, Y, and Z. These are the physical length, width, and depth of the stone in millimeters. And we have 100 observations here. So we scroll down, we see all the way down to ID 100. And we have all these different diamonds in each of those rows. So notice that this is already in data matrix form. We have one row per diamond, one column for each variable. This is exactly the structure from your reading when you looked at the data matrix tables in that chapter. And because it's already in this format, it's going to be very easy to work with Excel formulas. So let's start with creating some new variables. And now I made this top row bolded in a slightly different color just to highlight the variable names. You don't have to do this. So let's look at an adjusted table. Let's say that an appraisal firm, when they calibrate a diamond, they always add 3 percentage points to the raw table measurement for some reason. We'll call this adjusted table. Now, to calculate the adjusted table, we're just taking the table plus 3. So we could type in each of these numbers in the table column, or we can use a formula. So to do a formula, you type equals, and then you can type G2, or you could just click on that column, or in that specific cell in that column. You hit the plus sign and then 3, and you're ready to go. So this takes that observation, that 55 plus 3, to give us 58. You look here, it's in G, the table is a raw number. Here in K, it's a raw number. But when we go over to L, we see here the actual formula that we typed in. Now we can take this corner and drag it down, and that will give us values filling up those cells. In this case, as we go to column 3, the formula automatically changes to G3, which is what we want to see. G4, G5, and so on as we go down. Now, if you want to fill out the rest of the table easily, especially if you have like 1,000 or 5,000 observations, you can just take this corner here when that little black sign pops up for your mouse. Just double tap, and that fills out all the way down to observation 100. Now, let's build something that's actually a standard metric in the diamond industry that's not included in this table. We can do the price per carat. This is exactly how jewelers compare the value across stones of different sizes. So this is a worthwhile variable to have for us if we were doing something to work with this actual data set. So I'll go over to N1 and I'll type price per carat to create our new variable. Now we want to take the price of the stone divided by the carats. So we hit equals to tell it we're going to type in a formula. So we have the price, click divided, and then the carat. And enter, and this gives us the price per carat. So for this first one, it's $1,417. And again, just like before, we can pull this down. And in each of these, it goes from H2B2 to H3B3, H5B5, H6B6, all appropriately going down so that we have the right amount for each variable. Double tapping wasn't working there because we have this empty column here next to it, so I have to scroll all the way down and do this, which is much less convenient. So this is a great example of why you'd want to build a new variable instead of just eyeballing the numbers. So you don't want to compare a $326 half carat stone to a $2,000 one carat stone at a glance. This gives us a number that's more comparable. We might do this for if we were looking at like county level data, we might calculate the income per capita. So a very large county with a high population might have really high GDP, but we want to compare apples to apples. So if we compare a large county to a small county, if we divide by the population, we can see how well off the average individual is. So let's build another computed column. This time we can multiply instead of divide. So here in O1, we'll create a size score. And to create the size score, we'll multiply I2 by J2. So just multiplying the length and the width of the stone. Multiply and then click and select J2. And this gives us the size score, which we have filling all the way down to observation 100 or stone 100. So multiplying X and Y can give us a rough proxy for the surface area of the diamond. This isn't a perfect measurement. A real surface calculation would want to account for the stone's shape and things like that. But for a data set like this, it's a fine example, and it's a simple rough number to get. Now let's step back from building new columns and calculate some simple summary statistics. Let's look at the average price across all 100 diamonds. We can move over here to R1. I'll just type in mean price. And then to get the price, to actually calculate the mean price, type in equals again. Now, instead of typing in the columns because we want to do something, we don't have to type out the formula for an average, which is great. We can just type in the word average. So you start typing, a bunch of different functions come up. You select average. And then because we're doing price, we take H down from H2, highlight down to H101. You can also type in H2, put a colon if you want to do a whole column, and then type the second number, where it would end. So here we have the mean price, $666.19. Now, notice that I typed a label in R1 first, even though I'm not creating a new variable. In this case, I'm just creating a summary statistic. This is still a habit worth building. If you just put in numbers by themselves in a spreadsheet and you come back to it 6 months from now, even if you're the one who built it and you did this stuff for it, it's easy to forget what that number actually means. So this is just a simple way to keep ourselves organized and to remember what we've been working on. So now I'm going to use this R1, this exact cell in the next formula. So here I'm going to go over to column P and create a new variable. This one I want to divide each diamond's price by the average price. So we'll call this new variable price index. So we will type in equals H2, so the price for that individual unit, that individual diamond, divided by R1. So we have the price index. This price of 326 is about half, a little bit under half of the mean price. Now let's send that down. Now we have an error in each column. Now, do you see the problem here? Because this R1 is a relative reference, this is just or I guess R2 is a relative reference, Excel shifted that cell down each time we went into a new cell. It was great when we were calculating these other variables, but it's not great. See here, it's H3, so the price here divided by what would be below that, the average price. We go down here, H4, R4, H5, R5. So we're moving down and getting what would be these values, but these empty cells. That's not what we want if we're dividing by the mean. So we could solve this by replacing R2 here with typing in that number, but we don't want to do that. What if the mean price changes? What if we work with different data? We want to use formulas wherever possible. So let's undo this. So for this one, we'll use $signs to tell Excel that we want to use that cell and that cell only. So I'll type in equals H2 and give us that cell, H2. divided by, and now I'm going to use the cache signs. So cache R and then cache 2, and that selects this cell. So we see we have the same number here for the first diamond, but when I click down, you see now we get appropriate numbers. Here we have H3, so the price for diamond number 2, but it's still taking that mean price there, that R2. And as we go down, we're still dividing by R2. It locks in that cell. Now, in this case, every diamond's price index tells us how it compares to the average. So a price index of 1 means it's at exactly the average. Let's see if we have something at exactly the average. We do not. We have ones getting close to the average of 0.83, and then we have some really expensive diamonds down here that are like 4 times the price average. So that means that's 4 times the price. So let's do one more round of summary statistics. This time getting the complete picture for the variables, not just the mean. I'll go over here to T1. We'll type in sum. So we'll calculate the sum, the mean, the minimum, the maximum. If I didn't spell that wrong. The standard deviation, and the count. And then next to this, and you will calculate these. So to get the sum, you type in equals, and to call it the sum, you just have to type in sum. It's really nice. And then you put in a parentheses, and we'll do B2, the first one, and then we could type in colon, and then B101. And this gives us, it highlights the whole column down to the last observation. So here we have the sum for the carats are 37.2. Let's look at the average carat. So the mean is another term for average. Average is kind of a broader term, but that's the function they use in Excel to calculate the mean. So again, we'll do equals average. And we can do B2 colon to B101. And that again highlights that entire column, taking us down to the 100th diamond. This spits out the average carat, which is 0.3227. So let's find out the max. So let's do the minimum first. So equals min. And we'll do B2 again to B101. So this is the smallest carat, or the lowest value for carat. And again, we'll move on to the max. B2 to colon B101. So the largest is 0.96. So there's a considerable spread from the smallest value for the carat to the largest value. And calculate the standard deviation. This is another measure of spread. Equals STDEV. Now you have two options here you have a standard deviation P or standard deviation S. They use slightly different formulas. One is for the population, one is for just a sample. We'll say that this is just a sample and select that one. And later on, when this is something that you'll need to distinguish between the two, I'll tell you whether we're working with a population or with a sample. Again, we just hit B2, the colon, and then B101, last one. We calculate the standard deviation, and then the count to tell us how many we have. So count B2, colon, B101. That tells us there's 100 observations. That one we know because we have the ID variable going down to 100. So it does serve as a bit of a sanity check. And these are good things to do sometimes. So here's 6 very common functions. We can build a little table like that so it's easy for us to see it. You can also put it at the bottom of the column. That's especially useful if you want to take like the mean of each of these variables or something like that. How you organize it is up to you based on the data you're working with. I just want to end quick with showing you how using formulas can make it easy to change values or change data later. Why it's better than doing the math by hand. So I'll go into I guess cell M1 here, and I'll type the number 4. And then in M2, I'll type the number 5. So in M3, let's calculate something. Let's do M1 times M2 minus M2. So equals M1 times M2 minus M2. Oops. When you're working with capitalization, it's good to remember to not hit shift when you're trying to type in those numbers. So there we go. There's our formula. And that gives us 15. 4 times 5 is 20. 20 minus 5 is 15. So let's change the value from 4 to negative 22. This is going to change our answer. If we did the math by hand, we would have to redo all this. Or if we typed in here 4 times 5 minus 5. Here we just type in negative 22. And look at this, it spits out a different answer for us. So this is the exact behavior we saw with our adjusted table column earlier. It's the same behavior we had to override with dollar signs in the price index. So every formula in Excel is either watching a cell relatively or absolutely. So each one of these moves, things like building a new column, calculating a summary statistic, locking reference with a dollar sign, you're going to use these again on this week's problem set on a different data set. So the buttons and the formulas are going to be identical. What's different here is going to be the data and the story that the data is telling. Now, I'm trying to use actual data sets for our walkthroughs and for our assignments rather than just a list of random numbers to kind of give you something to be applying. That you can take this, instead of just looking at a blank data set, it's something that kind of tells a story. In this case, we're looking at, learning a little bit more about diamonds. It just makes something a little bit more practical because it can be tough to do in statistics.